Okay, I am unmuted now. How are you?
I'm good, thank you. Yeah, I just took a minute to set up the live stream, so we're streaming on YouTube at the same time.
How exciting.
Yes, you'll be a YouTube sensation.
I always wanted my 15 minutes of fame, and this is going to be like an hour and a half. So, can't complain.
I'm good, thank you. Yeah, I just took a minute to set up the live stream, so we're streaming on YouTube at the same time.
How exciting.
Yes, you'll be a YouTube sensation. Okay. Do you have some introductory slides you're going to show, and you're okay with that?
Well, I have some things I can show, but maybe what I would like to know is whether people want to bring anything up first. Are other people allowed to share their screens as well? If they have, say, a slide to support some point they are making? Okay.
Yeah, this one is a Zoom meeting, so everyone can be unmuted and share their video and share slides if you want them to.
So here's what we can do. Since we are winging it anyway, I can ask for people to, if they want to introduce any discussion. If, as often happens, nobody wants to talk, I will. I do have some slides to get things going.
Okay.
And I guess, yeah, we start in about 5 minutes.
Yeah. Yep, we're on and ready to go.
I see you are at Anchor.
I am. I got special permission, had to go to special training. So we've been running this along with ISG staff from in their suite.
Right.
So it's been great to just be here with Ryan, and then yesterday Gokhan was here. Today he's back in his office. So
yeah, no, that must feel weird actually being in the office, So
yeah, I haven't seen anyone else other than our.
I thought about coming up, but then I was told, no, you don't need to do it. So so here I am. Yeah.
Yeah, the question just came up for some people who either have a lot of children at home where it might be noisy, or unstable internet.
Okay, no, I just have Anne, who is not a child, so I think she's watching downstairs. So yeah, no, we're all well set up, and I don't even know who is here. I guess I can look at it.
Yeah, if you look at the participants, it'll bring up the list.
There's about a dozen people, no less than that, more like 8 or 9 people.
Mm-hmm. And so then in that chat, you can chat with the whole group. They can chat with you. And then the gray button at the bottom, you can chat privately like you did. So that's fine. And I just wanted to double check. So you do not want this recorded. Is that correct?
I don't care one way or another, to tell you the truth. I mean, I don't see the need to immortalize this thing. But, it's whatever.
Yeah. All right, well, when you get started, I'll just hit record. It was just a suggestion from ISG, and then we don't have to do anything with it, but it's like you can't go back, once it's passed and not recorded, then it's gone forever.
Okay. All right, so I am ready to start in a second. So I guess what I do is I will introduce things, and then if I want to show something, I just share my screen.
Right? Yeah. Mm-hmm.
Now, what about if other people want to share their screens or whatever? Obviously, I have to stop sharing myself.
Yep.
And then they can just share. I mean, they just push the button, or are things restricted in any way? And are you controlling them? I'm not sure how you set this up.
No, they can go ahead. It's just that, like you said, one person at a time.
All right. Hi, Luisa.
Hi, Rolando.
You look bored.
No.
Okay, so it's 3 minutes. So we'll let people some time to filter in. Yeah, I see a whole bunch of more people that joined. So I will wait until 1 o'clock by my computer's clock here, and then we can start. For those of you who are there, We've never done this before, either a virtual meeting or a discussion only session. So we are winging it a little bit. What I wanted to say is that we could start by asking you guys, the audience, whether there were any pressing topics that you want to introduce and discuss. You have the ability to do that by voice, or you can support it using slides, in which case you will be sharing your screen. After you are done making your point, you will unshare the screen, or you'll stop sharing so that the next person can go. If nobody has any remarks to make to begin with, I think I will get the thing rolling by showing some of the things I presented yesterday in the reports from the various working groups, and what I think are the big things facing WACOM and the whole atmosphere working group at the moment. So, okay, 2 more minutes, and that's the way we're going to do it. So think about what you want to do, and in particular, whether you want, you have a topic, hot topic that you would like to see discussed here, as to how WACOM works in the future.
I see Xiaohong is pretending to be in San Francisco, but I think we should all have the backgrounds of Breckenridge or something. Pretend we're all up
I have it in my bed, but, at least the bed is made, so it's good.
Your camera ready to
more exciting back there.
And your camera ready to capture.
No, the thing is, my workstation, my computer is here in my bedroom. A fairly large bedroom, and so I didn't think of moving it for any of these virtual meetings and whatnot. So here we are.
No.
But I do make care of them. Make sure to make the bed.
Where's that, Chuck?
Especially mornings when I'm having a meeting. I see Dan is there. Chuck is there.
No,
okay.
Chuck is apparently somewhere where there is that Golden.
Chuck, I don't know what he is doing. I thought that's some kind of
You need to unmute, Chuck.
Chuck, you need to unmute.
It's Wonderland Lake. There were there were 10 paragliders up at the same time.
Right. Lots of paragliders.
Oh, wow.
So less than a mile from my house.
Okay. So it's 1 o'clock, so I think we might as well get going. I will repeat once again what I said 2 minutes ago, which is we haven't done this before, so we are going to wing it. And the first thing I wanted to ask is whether anybody has any specific things that they want to bring up as a topic of discussion. And if so, you have the ability to just say so in words, or if you have a slide or two to support what you want to say, you can share your screen. Anybody? Okay, so I'm gonna get the thing rolling myself then. I am going to, let's see if I can figure out how to do this. Share my screen. And which screen do I want to look at? Let me see. Right, okay, we are gonna share this one now. And this is from yesterday's working group wrap-ups or updates. And I think there's a number of issues facing WACOM, but perhaps the most important one is what the future of the model is in a world where CSM has been asked by the Scientific Steering Committee to come up with a new version, what they call a workhorse model, that will be the official NCAR CSM model for a future CMIP exercises. Okay, and I think we finally have gotten through to the community that a model that doesn't generate a realistic QBO internally is behind the times, and that is required. All right, in order to do that, of course, you need high vertical resolution through the free troposphere and the lower stratosphere. I think, well, I will give you some background. I am a member of this task team that CSM recruited to look into this after the recommendation from the Scientific Steering Committee. We've done lots and lots and lots of simulations. And what we have found out is that if you want to get a QBO where explicitly represented Kelvin waves have a substantial role in driving the oscillation in the lower stratosphere, and in particular below 50 to 70 hectopascals, you need a vertical resolution of probably 500 meters. 600 meters is still in the running, but it's not clear to me that it will be as realistic as 500 meters. And in fact, it could even be that you need lower resolution, but 500 meters seems to be a practical, acceptable resolution value for, again, from the top of the boundary layer through mid-stratosphere, 25, 30 kilometers. So this model that we are trying to shoot for, this workhorse model, is not going to have more than 80 to 90 levels, because CGD wants to add more levels in the boundary layer, as if I didn't have enough. Then essentially that puts a strong constraint on what we can do in terms of resolution and a model top. It's clear that we cannot put the model top anywhere above 80 kilometers and have a model where the number of levels is less than 80 or 90 if you include the additional resolution in the boundary layer. The model also should have various suites of coupled chemistry, because, of course, that is the point of having a workhorse model. It's a model that you can use to do, say, future climate simulations, where you do not know what the chemical composition of the atmosphere is, because it will be evolving. And so you need chemistry to do that. So we will have the TSMLT. Presumably, we will have MA for some applications. And I know that the Chemistry Climate Working Group people are trying to look at some kind of simplified chemistry scheme to make it less expensive than TSMLT. Okay, I guess two things about a model with enhanced vertical resolution. That is that it can simulate a realistic QBO, but we are finding also that it improves the dynamics in the free troposphere. In particular, the MJO looks a heck of a lot better than it ever did in any of the CESM models until now. So that's a plus. A minus, of course, is that this model will not be suitable for middle atmosphere studies. I think I will be, myself, will be comfortable using a model like this to study the troposphere, maybe the stratosphere. Once you get into the mesosphere, you're beginning to treat that as a sponge layer. There are caveats to that, but essentially, if you want to do mesospheric, lower thermospheric science, you need a real wagon. And the idea is you will have to build that model on this workhorse model. That shouldn't be too difficult, nor too different from what we have been doing up to now. But obviously, a model that has a top at 80 kilometers and where the resolution degrades rapidly above mid-stratosphere is not going to be suitable for a lot of the things that WACOM is being used to today. So those are the pluses and those are the minuses. There are other implications, but before I go into those, I would like to know if anybody has any comments. I also have other presentations which I can turn to, where I can show you the kind of level schemes we are looking at, the kind of results we are getting for the role of the resolved Kelvin waves in the QBO and so on. So I can show all of that if people want to. But before I do any of that, and before I get into the discussion of what I think the implications of this workhorse model are for the future of WACOM, I wanted to open it up for any comments that you might have. Now, let's see, I need to stop sharing, which I have just done.
So there are questions in the chat.
Okay, there are questions in the chat. Let's see. From to everybody, how much of an enhanced resolution is desired? How is this determined? How much additional computer time will be required to run the model with enhanced resolution? Okay, so right now, horizontal resolution is 1 degree approximately, and there are no immediate plans that I know of to change that. Vertical resolution in our standard models, both CAM and WACOM, in the lower stratosphere is about 1.25 kilometers. At that resolution, you cannot produce a realistic QBO. You can get something in there that looks like a QBO, but in the lower stratosphere, it's not realistic. So the idea of 500-meter resolution from the top of the boundary layer through the mid-stratosphere comes from the need to simulate a QBO. So we know that we need that, and that's how that was determined. As to the cost for these things, well, it's linear in the number of levels. So, I mean, the current WACOM has 70 levels. So a workhorse model that ended at 80 kilometers will have about 80 to 90 levels, depending on how many levels they add in the boundary layer. So in terms of WACOM, it will not, well, in terms of WACOM, the workhorse model will not be a big change. However, if you look into the future for running WACOM, I think you are looking at about 110 level model. And the reason for that is that you want not only high resolution through the mid-stratosphere to simulate the QBO, but you also don't want to allow too much degradation of the resolution as you get towards the top of the model, because in that case, the model would not be suitable for the kinds of studies that people do for the middle atmosphere. So there is going to be a choice. You can, if you are interested in stratospheric science, in the UTLS, in chemistry coupling, you probably can use the workhorse model once it's finalized. And the cost of that compared to current CAM, which I think has 30-something levels, will be about a factor of 2.5, just going by the number of levels. So you could use that. If you are going to do mesospheric, lower thermospheric studies, and you want a QBO, you cannot get away with less than about 110 levels. I don't know if that answers that question, but if it doesn't, please speak up. Remember to unmute yourself.
There are 3 more comments.
Okay, the other comments are high vertical resolution is also important for high clouds. I agree. Any UTLS processes are going to be much better represented, and not just clouds, but also the position of the tropopause, tropical tropopause, the distribution of chemical species in the near tropopause region are going to be much better resolved at 500 meters. You said yesterday, 2-degree model has been validated. Have you looked at going from 1 degree to 2 degree impacts on the QBO? No, I have not. And in fact, I think Yaga may be around. I know that she has attempted to do the QBO high vertical resolution at 2 degrees with probably mixed success. Yaga, if you are there, could you comment on that?
Yeah, I haven't looked at it in a WACOM runs, but when we, in 2015, did it in CAM, it degraded. So it was not a QBO that we would have been happy with. But I have not looked at it in the 2-degree model that supposedly has been validated. I guess maybe somebody who's been running it can answer.
Right.
Or is that 2-degree model nudged QBO?
Yes, when we ran the deck at 2 degrees, we nudged the QBO.
Yeah, that's what I suspected. So then we don't really know, right? What
Yeah.
Without it.
By the way, that 2-degree model where we notch the QBO, of course, is based on the 70 level model. So coarse vertical resolution through the lower stratosphere. So you couldn't get a realistic, any QBO anyway. However, the idea that you might try to get the 2-degree model and see if you can generate a realistic QBO is something that ought to be tried. There's 2 possibilities there, that the coarse horizontal resolution overdamps the QBO simply because this is such a equatorially confined phenomenon that needs high horizontal resolution in addition to a high vertical resolution. Or it may be that once one goes to an SE version, which is much less numerically diffusive than FV, a QBO might be possible even at 2 degrees. So that's definitely on the agenda of things to do. Thank you. Okay, March to everyone. On the flip side, those interested in strat mesochemistry using SD or space weather may not want the additional cost. So we need the flexibility of choice in the number of levels. Yeah, I completely agree. So, I mean, you can always revert back to a 70-layer configuration. And then Stephanie, to everyone, how does the model do with respect to age of air? I don't know. And I'll tell you why I don't know. It's because it's so new. We are just finding out right now. It might have some impacts on age of air. So yeah, we will have to look into that. Thank you. Any other questions? Okay. Let me show you a couple other things. Let me find the other presentation. Hang on, there was something else I wanted to share, but I have to find where I put it. It's not that. Okay, yeah, here we go. Okay, I am gonna share screen here with you. Bear with me because I have to find what I want here. So why isn't this coming up? Okay,
You're
here
just,
we go.
there you
No, it's on now. No, but this is what I was sharing before. Let me see. And this is what I want to share. Okay. Let's see. Okay, so this is further to the question of how the number of layers affects the QBO, and all of this, of course, is in the context of the so-called workhorse model with a relatively low top to it. So what you see in your screen right now is the grids we have been looking at. A lot of our experimentation, where we determined that a resolution of about 500 meters was necessary through the lower stratosphere, was in the context of what is marked there as L91. That's a 91 level model to 80 kilometers. And that has a resolution of 500 meters down below, tapering off to a coarse resolution of 3 kilometers at 80 kilometers. With that model, we compare resolutions in the lower stratosphere between 1,000 meters, 900, 800, 700, 600, and 500. We determined that 500 gave by far the best, gave the best QBO, the most realistic QBO. The 91 levels, of course, was deemed to be too many levels, so people started to experiment with that tapering to a coarser resolution at the top. And that's what you see there in the green, blue, and red dots. The red one was discarded immediately. It didn't, I think it even failed to produce a QBO at all. The blue one produced a rather wimpy QBO. I will show you that as well. And the green one produced a QBO that looked realistic in the lower stratosphere, but lost amplitude at higher altitudes. And I will show you that comparison next. This is a comparison of all of these cases, all with a top at 80 kilometers, but with tapering at different places. And you can see that the one in blue is when we taper to 3 kilometers at 80 kilometers. In the red and the orange, we taper to a resolution of 6 kilometers at 80 kilometers. All of them have a QBO period that looks reasonable compared to the observations in the black dots. And they have an amplitude that looks not good when you taper at 20 kilometers. It looks okay in the lower stratosphere when you taper to 25. But it loses amplitude in the upper stratosphere, and then those can be compared with the blue curve. I am referring now to the right panel of this figure. It can be compared to the blue curve where we taper to 3 kilometers at the top. And that one has an amplitude in the upper stratosphere that is consistent with observation. So, you know, you get what you pay for. And the idea is that you have to both have high vertical resolution in the lower stratosphere and not overdo it with a too coarse vertical resolution at high altitude. Let me see what else I have here. Well, this is the way the QBO looks in all of these cases. The base case on the top panel is the QBO when we have 500-meter resolution in the lower stratosphere, and we degrade or taper the resolution, starting at 25 kilometers, but only to 3 kilometers at the top. That QBO looks the best compared to observations. In the lower left, we have what happens when we start tapering at 25 kilometers, similar to what happens at the top, but we taper to a much coarser resolution of 6 kilometers. QBO looks comparable in the lower stratosphere. It loses amplitude in the upper stratosphere, the same as was shown in the previous slide, where I did the coherence analysis of the QBO in the QBO frequency band. And then finally, bottom right is when we start the taper, again to 6 kilometers at the upper boundary, but we started from 20, and that one pretty much kills the QBO. The amplitude is much lower in the upper stratosphere. It looks reasonable only in the lowermost stratosphere. I think I would like to see the workhorse model not to adopt any of these tapers that are too dramatic, because it will make it more difficult to build Wacom on top of that. Whether I will prevail or not, well, we'll see, but we will certainly try to do this. This is probably too technical, so I'm not going to show it here. And I'm just going to give you my conclusions. I mean, I can go back to any of these other slides where I document exactly what is happening with the EP flux divergence of Kelvin waves. But instead of that, I think I will give you my conclusions, which are that, well, you cannot taper to 6 kilometers starting from either 15 or 20 kilometers. I mean, that certainly reduces the number of levels to 63 and 71 respectively, but at the cost of essentially having a stratosphere that is not realistic. Tapering from 25 kilometers to 6 kilometers is comparable to the base case in the lower stratosphere. It is not so good in the upper stratosphere. And you can ignore the next comment because I haven't really covered that. And there is also another way to address that, and is to look at new grids that do not degrade the resolution so drastically at 25 kilometers. And this is something that Dan Marsh proposed. Put a lid at 80 kilometers, don't count any of the little crosses above 80 kilometers. The blue curve in this figure shows a grid that tapers to 6 kilometers from 25 kilometers, starting at 25 kilometers. That grid, as I have mentioned already, has a QBO that is reasonable in the lower stratosphere, is the amplitude degrades in the upper stratosphere. So the question is, for that purpose, and also so we can believe anything that any of the simulations in the upper stratosphere, how about if we taper to 3.5 kilometers at the top boundary? That's about half the scale height. And we pay for that by lowering the top boundary from 80 to 75 kilometers. So the red crosses and the blue crosses are two grids that have the same number of levels. I think it's about 81 levels in both cases. And the only difference is that the blue goes to 80 kilometers, but tapers to very coarse resolution, whereas the red goes to 75 kilometers and tapers to much finer resolution, 3.5 kilometers at the top boundary. Tests with the red grid are being conducted right now. We will see how well the QBO does in that case in the upper stratosphere. Let me see if I have anything else. Well, okay. Before I go to the next thing, any comments or anything you would like to show on any of this?
So Rolando,
Yes.
in a few sentences, can you, or Yaga, there's some baseline gravity wave tuning that you put into the level 81 and level 91 that you're not changing in any of the other grids, right? I mean, you can play around with the tuning of the gravity waves and resolution, and you can get different results. Am I correct in that?
Right. Gravity waves will only get you so far. So what we have found is that if you make the resolution too coarse, you will be able to get a QBO simply by enhancing the gravity wave forcing. However, that QBO is not realistic, because to achieve realistic period, if the QBO doesn't descend close to 70 hectopascals, If you force it to do so by really enhancing the interactions of the gravity wave with the mean flow, you can get the QBO to descend below 70 hectopascals, not very realistically, and also you shorten the period to about 24 months. So it's like you cannot have both things in a model where resolve waves do not play a role. The only way that you can make the resolve waves play a role is by getting down to a resolution of about 500 meters in the lower stratosphere through at least, as we have said before, 25, 30 kilometers, which is what all of these grids here show.
Okay.
Does that answer the question?
Yes. Yeah.
Anything else? You know, at this rate, I'm not going to have enough things for an hour and a half, you know? I mean, so I don't know if you guys want to do anything else, but I'll throw in a few other ideas.
Rolando?
Yes.
I mean, I don't know if you want topics other than the QBO to discuss.
Say that again, please.
Are you asking for suggestions on topics other than the QBO?
Yes.
Yeah, okay. So I really think we should be talking about the transition to the spectral element die core. And I understand finite volume is going to be the workhorse model for CAM and I guess WACM, but CAM-CHEM, and this is the WACM CAM-CHEM working group discussion, right, is moving to spectral element because of the regional refined capability. And so, or, you know, is at least putting a lot of effort into looking at those, that model.
Right.
And so the question is, are we staying with the CAM, you know, our efforts going to be more along the CAM lines? Are we going to be trying to, you know, follow CAM-CHEM's example? Because I think there's a lot of very interesting science in the MLT that could be done with a regionally refined model in terms of looking at better resolving the gravity wave influence on the MLT structure in the regionally refined area. So I, you know, it seems to me that we need to have some discussion about, you know, what priority migrating to SE is. I mean, SE is a potential pathway to non-hydrostatic. Or, you know, whether we skip over SE and go to MPAS, you know, is another question, if we really want to get down to higher res. So just, you know, future directions you're talking about, I just thought that those are topics we should be discussing.
Right. Okay. So the answer is yes. Now I will elaborate on that a little bit. Obviously, one thing that WACM cannot afford to do is to try to do our own software engineering. I mean, I don't think we can, because we don't have the resources. So in some sense, we have to stay with what CAM is doing. However, the push with this workhorse model is to eventually realize it in the context of an SE core. So that's what I say. The answer is yes. I think this is the way that CESM is moving anyhow. As regards MPAS, I don't hear too much about it. I think now we have an SE core that has been shown to work both in the context of CAM and WACM. So as I saw, in fact, I showed you yesterday the simulation of the QBO that Peter Lauritsen had produced using a 110 level version of WACM with the SE core. So we had to tweak some of the gravity wave parameters, but otherwise the QBO looks great. 500-meter resolution down below. So in that sense, similar to these FV simulations I have been discussing, but in the context of SE. So I think insofar as CSM is going to one of these cores, and most likely SE from the looks of it right now, we are already in doing what you suggest we should be doing. I mean, maybe Peter, who I see is here, would like to have some comments on that.
Yeah, can you hear me, Rolando?
Yes, I can hear you. Go ahead.
Yeah, just to mention the MPAS dynamical core, we're making progress, but we're at the simpler model stage of testing. And we don't expect to have like a fully coupled CAM version of MPAS ready until like early 21. And there are some science issues we need to think about, since MPAS is on a different vertical coordinate. So we have to make sure that that works properly. So realistically, in the next half year or longer, I don't think we're going to be able to run realistic vacuum simulations with MPAS, but it is our intention to have a version of MPAS ready. We just need quite a bit of time to get there.
Mm-hmm. I mean,
and with respect to spectral element, in my personal view, the purpose of the 2.2 release here is kind of to provide a baseline where we both have spectral element and FV3 in there for the community and NCAR to evaluate.
Right. Yeah, I mean, I don't really have a personal opinion on any of this. I mean, aside from the fact that I think Wacom needs to stay wedded to whatever CAM is doing, again, because I don't see how we can go off and develop our own model, given the fact that we have essentially zero resources. However, CSM seems to be moving towards SE. I don't know what role MPAS will play. And I don't know what the trade-offs between SE and MPAS are. So yeah, I guess these are things we'll be seeing in the future. But in the context of either one of those two dynamical cores, I presume you have the ability to do regional refinement. SE is much farther along. It has already been shown to work both in the context of CAM and Wacom and in the context of regional refinement. So I think that may be the next core, but who knows? Right? I don't call the shots on that. Any other comments?
Yeah, the attractive feature of MPAS is it's been developed at the weather scale on non-hydrostatic scale. So one advantage of getting that into CSM is if you want to do a non-hydrostatic model, at least the dynamical core, that's what it's been developed for. I just wanted to make sure that everybody knows that that's not going to happen within the next 3 months or 6 months. It's a little further out. So in the interim, we need to switch away from FV, and that's where SE is taking the place, or we're trying to make SE take the place.
Right. So SE continues to be used, and otherwise it continues to be used in the same way of FB is. I mean, with vertical remapping, right? So it's a hydrostatic model in that sense. Okay. So that's where we are with that. I don't know then if that answers your question. I mean, obviously there is not a completely definitive answer, except that I think NCAR as a whole is moving the way you suggest we ought to be moving.
Okay, but we don't really have a timeline because I don't think we can support, we need to, if SE is the future, I just wonder if it makes a lot of sense to devote a lot of time to FV once you settle on a workhorse model. I feel like we're getting pulled in two directions. If the future of CAM is definitely going to be SERR, and CAM is maybe behind CAM in terms of sticking with FV for things like subseasonal to decadal prediction, then where do we sit?
Right.
Can I?
Yes.
This is Julio. I'm not convinced that FV is the the workhorse being considered by anyone in the next 2 years. I think our intention is to move away from FV as soon as possible in the next phase of model development. So I think as of release 2.2, I think within AMP we'll be focusing our efforts on SE, not FV, including the vertical resolution development.
Right. Yeah, I mean, I tried to say that, but maybe I didn't say it as plainly as Julio said. We have been working with FV because that's what we have now and where we have some background. I think any of these results will be easily transferable to SE. I mean, in fact, the simulation of the QBO that Peter produced already shows you that you can do that. So I will expect that a workhorse model, once it is released, will be a spectral elements model. As for MPAS, not privy to what the thinking is as to when that might come in.
Yeah, and then the only reason I brought up MPAS is because in the long term, we probably want to go to even regionally to even finer resolution than say 12 or 12 kilometers. So,
Yeah.
then
right.
non-hydrostatic core, that's all.
Yeah, once you begin to get much below 10 kilometers, then you really need to be thinking non-hydrostatic. So that much is true. Yeah. Anyway, that's like the promised land, and like Moses, I am only want to see it from afar. So it's for you guys to worry about that. But obviously, if you want a non-hydrostatic model, which I suppose is diffusion in some sense, that will have to be impasse. But yeah, okay. No more to say about that from my side. Any other questions from the peanut gallery there?
I have a question for maybe for Julio. At the end of this morning's AMWG session, I think Gokhan was saying that decisions will not be made till probably next January or something about the future dynamical cores, whether SE or other cores. Maybe I misunderstood that. You just said that you're committed to SE.
Well, I'm trying to be realistic rather than political. Oh, go ahead, Peter. Sorry.
Yeah, I didn't get to mention that. I just think everybody ought to know that the SSC would like to decide on a workhorse dynamical core like early 2021. And when I say workhorse, it's like for standard IPC type applications. So it's likely 1 degree model with X number of vertical level that's going to be used for fully coupled model development. And that's where we're looking at SE, FEP, and MPAS for that.
But Peter, wouldn't you say that it's fair to say that we won't be choosing any die-core that can't reproduce or improve on what SE is already doing?
Yeah, I guess FV is our baseline, yeah.
Which is our baseline? Spectral element.
I think he said FV is the baseline, finite volume.
Well, we're comparing against FV, which is what we're using now, and that's what we're comparing SE to. And then moving forward, since we need to move away from FV in order to have regional refinement, scalability, and so on, I think we should be comparing to spectral elements because that's the one that's furthest along and most mature in the development process. And then we'll see how FBC compares to that and how MPAS compares to that. So yeah, I agree, Julio.
Right. I would add on all this that if the responses seem a little bit murky, I guess it's because they are. I mean, in an ideal world, we will be saying SE and that's it, and we will know what the direction is. But the desire at some point to go non-hydrostatic means that MPAS, I guess, comes into consideration. My personal assessment of this is that the workhorse model will be released as an SE-based model. And beyond that, I don't know. So maybe somebody else has a different idea. And if so, you can say so. So nobody seems to have a different idea. So that's what I hear from working with the task team people that, yeah, we have been doing this in FV. There is no point in trying to refine too much what we have been doing in FV, since we know the overall lay of the land as to the requirements for vertical resolution and how this whole thing works together. But that the actual model to be released, it will most likely be released in an SE version. Anything else along those lines? Okay, I am going to introduce another topic, which is just pertains to WACM, and it has to do again with vertical resolution. If you look at the two grids shown in this picture, the black one is our current 110 level grid. That's the one where we get very nice results for a QBO, and otherwise the resolution is similar to what we have in the 70-layer model, actually a little bit better as you go to the model top. That's 110 levels, okay? And so it's a factor of 110 over 70 more expensive to run than the standard Wacom. But I think for many purposes, it may be worthwhile. Looking into the farther future, where presumably we might have more computational resources, it has occurred to me that tapering to a finer vertical resolution at the top might buy you two things: the ability to begin to see what the SAO due to resolved waste might be doing in these models, and having a mesosphere, lower thermosphere that is now well vertically resolved. So that's where I think researchers in the middle atmosphere using Wacom ought to be going to. Of course, other people will have different ideas, including, well, we can't afford it. But I will argue that the differences between a 110 and 136 level grid are not enormous. 136 is about twice the cost of what we are running now. We should have a new machine here within the next year or two. So this is something that folks who have been working with Wacom in that time frame and want to look at the physics of the stratosphere and mesosphere may want to consider. So this is apropos of nothing, but I think our results on the importance of vertical resolution have opened a new realm of physics that ought to be looked at. Hasn't been looked at before by anybody. And you know,
Rolando, out of the runs we have proposed in the fall, can we just not use this 136 level grid instead of 110?
Sorry, say that again.
Since we have the NSC allocation to run with 110 levels, if we run in economy, we should be able to afford the 100.
That's a possibility, and we can certainly look into that. The point of 110 is because Jag is referring to an NSC proposal that was just approved, where we wanted to compare simulations of Wacom at 70 levels versus 110 levels. We are trying to leverage stuff that has already been done. And for the purposes of CMIP, we have run the 70-layer model. I think we have at least 3 realizations, and we want to have like a 5-member ensemble. And then we want to do something similar with 110, for which I think we have 1 realization. So of the historical period I am referring to now. And so, you know, the question is, if you now move to this more expensive grid, of course, you are bringing in additional cost for an NSC proposal that was not funded the full request anyway. I will certainly be willing to discuss that with you. And, you know, it's a possibility. We can simply substitute 136 for 110. But what I'm trying to say is, insofar as forming and small ensembles, for 110, we already have a head start. For 136, we'll have to start anew. So, I mean, to me, this is a little bit like the promised land, in the sense that now that we know the importance of vertical resolution, we have a whole realm of physics that we ought to be looking at. And that perhaps the way to look at is with these grids that have a finer vertical resolution high above. And in that sense, I look at this as a separate issue from what we wanted to put into the research that is being made possible by the NSC proposal that was just funded. I'm certainly willing to entertain ideas, and well taken your point otherwise.
Have you actually run with this grid to see if anything's improved, like the SAO or the tides?
No, I mean, that's what I wanted to do it, because I mean, there's 2 things that can happen. The SAO is not going to improve, or the SAO will improve. If it improves, then it shows you that vertical resolution also matters as you go at higher altitude. You may ask, why not 500 meters throughout? Well, for one thing, it will be very expensive. But for another, the expectation is that vertically propagating Kelvin waves will have a longer vertical wavelength as they go higher up in the atmosphere, because all of the slower, shorter wavelength waves will have been dissipated below. So to some extent, the idea is to match the grid to what you expect will be there physically. But no, I haven't checked what the SAO may look like. There are other reasons why an SAO might not arise regardless of resolution, and that may be that the convection schemes in our current models do not excite high frequency Kelvin waves efficiently. And that's something that has worried me for the last 25 years. It's never been addressed because we don't control what CAM does. But you know, it's a definite possibility.
So the
Rhonda? Oh,
Yes, sir.
sorry, Anne, you go ahead.
I was just going to say higher vertical resolution could help with the diurnal tide also, which is
Yes.
fairly poorly simulated.
Yes.
So, I mean, you're almost getting to the resolution of Wacom-X in the mesosphere. So Wacom-X is 4 grid points per scale height. You're looking, so that's 1.75. You're saying 2 kilometers
Yes.
here.
Yes.
The idea that Wacom-X is built on top of Wacom, and if you're going to be tuning things to produce the best possible tides and everything else that then propagate into the space weather region, there could be an argument for, you know, sucking it up a little bit and just adding a few layers to get this to 4 grid points per scale height as opposed to 2. I mean, it's not much more. I don't know how many levels it would add, but you know, I mean, if a lot of the workhorse simulations are going to be done with CAM 75 or whatever you want to call it, lid, 75, 80 kilometer lid, then we really are talking about Wacom focusing on the MLT,
Yes.
or at least this, you know, I guess upper stratosphere to and upwards. So in that situation, you know, maybe we try and unify our grids between Wacom and Wacom-X in the mesosphere and up.
Right. I mean, let me make a remark and answer to that, and then I know that Simone has raised her hand, her virtual hand, so she gets to go next. But that's definitely a good proposal. I hadn't thought about that when I constructed this grid. It was just something to give us an example of where we might want to go. The fact that it will dovetail with what Wacom-X is doing is in fact another argument for considering something like this, in addition to the possibility of improving the SAO, in addition to improving the simulation of the tides. So I think there's a lot of wins for Wacom, but it's going to have to be our model. I mean, CGD is not going to help with anything beyond about 30 kilometers. So essentially, we keep the workhorse grid to 30 kilometers, and we take off from there for our own purposes. That's the way I see all of this. I don't know how else you can fit all of these interlocking parts together. I'll stop there, and then Simone had a question.
Yeah, this is also about the grids, because you just said, I mean, do we merge Wacom with Wacom-X, or do we merge it with the CAM model, with the workhorse model? Because I thought the reason was to keep the higher vertical resolution in the stratosphere is that it can then right away merge towards Wacom. That was kind of an argument to say we still want to keep those models, at least the lower part, the same, and then Wacom will build on this workhorse model. And the other question I have is really, I mean, there's a lot of resources going now into this development, but don't we need also a lot of resources to then develop the Wacom grid, because it will have a whole different set of questions? And I mean, that's what you just said. There's only resources available for the workhorse model, but shouldn't it be also for Wacom? Because Wacom will still be a really important model for middle atmosphere studies.
All right, so I'm not completely sure what you are saying, so let me go by parts. I think there's no question that you must build Wacom on the CESM workhorse model. And I will propose that the grid match exactly the CESM workhorse through 30 kilometers, 25 kilometers, whatever it is that they are beginning to taper, right? But any of those tapers to their upper boundary at 80 kilometers are not gonna be suitable for middle atmosphere studies.
Yeah, that was my question, I guess, because if you do taper, that means that's not what Wacom will follow on. So it will not just be, Wacom will not just follow above like it does currently. We are not just setting on top the levels of the current, of the lower top model, basically, the new low top
Well,
model.
actually, even now, Wacom doesn't follow the CAM levels above, I don't know, probably 20 hectopascal. I don't know, but something like that.
Okay.
Because essentially current cam, which has a top, I think around 1 hectopascal or something like that, Yaga can correct me, degrades resolution very rapidly in the upper stratosphere. Wacom doesn't do that. So in that sense, this will not be a change in operating procedure. For purposes of climate, whether you have a finer grid above 30 kilometers or the strongly coarsening grid that the workhorse model will have, I don't think that will be a major impact. But to do mid-atmosphere science, you cannot work with such a coarse grid in the upper stratosphere and mesosphere. So this is what I'm saying, that Wacom will have to be built on top of the CESM workhorse, and will have to keep, I mean, it will be desirable that they keep the same level of structure to about the point, the level where the workhorse begins to degrade resolution. We don't want to degrade resolution so much. Okay, so that's the way I see it. I mean, it's up to you guys. I mean, you are the ones who are going to be working with this thing in the future. So I am telling you the way I see it from the point of view of my understanding of the physics of the middle atmosphere. Okay. Anything?
Yeah, I mean, so Simone, it was my suggestion that we limit the workhorse cam model to no larger than 2 grid points per scale height, because I didn't really see the point of having an extended sponge layer where it's really stopping at 80, but only in name only. I mean, that's, you know, really, I mean, I don't, so keeping it at 2 grid points of scale height, but taking off 5 kilometers from the top seemed a bit more scientifically defensible model than you know, or than just sort of burning computer time to have a model that, you know, I wouldn't even bother to look at above 40 kilometers or something like that. So, so that's the reason. Now, you know, I'm arguing, I agree that that's maybe not consistent with the idea of running Wacom and Wacom X on the same grid. But I still think a 6 kilometer spacing is you know, of no use to us in tuning the what's coming into the lower mesosphere than maybe a 3.5 kilometer grid.
Yeah, and that's what's shown in this slide that is currently on the screen. The blue crosses are what CGD have proposed, and we have actually run some experiments with that, which I discussed earlier. And the red crosses is what Dan proposed. There's a grid like that. It's being tested right now. I expect, in particular, the QBO will look better in the upper stratosphere. I don't know if it will be totally comparable to the 110 level grid, even when you chop that off at 80. But at least it will have a resolution that is credible in terms of what you expect the dynamics to be doing there. If you go to a 6 kilometer taper, what you are saying is the entire mesosphere is a sponge layer. So why do that? It's preferable to just give up 5 kilometers at the top and instead taper to 3.5 instead of to 6 kilometers. So that's the argument. And I think we may very well go with that in the workhorse model. Okay, is that clear? It's hard to know if anything is clear because I cannot see your faces. Mostly I see either some letters or I see a picture of people. And but anyway, I presume insofar as there is no responses, you are all nodding your head and say, okay, that makes sense.
Yeah, thanks Orlando for explaining.
Yeah, anything else on this?
Rolando, I raised my hand. Maybe you saw it.
Oh, okay. Well, and the problem is that I am not seeing everybody here who raises their hand. So I am on screen sharing.
I just want to make sure no one is in front of me.
You have raised your hand now. Okay, go ahead.
Okay. Yes. First, I want to second what Anne and Dan mentioned on the higher vertical resolution for resolving tides. That's exactly why we want to increase our Wacom X vertical resolution to 4/4 scale height vertical resolution. So what we will do probably, if we want to merge with the workhorse model, we need to kind of merge down and increase the resolution at lower altitude. So I don't know, maybe we'll have a 170 level model or something, but that's okay. One thing is, if you are using Wacom, not Wacom X, if you're using Wacom and try to get a better tides, maybe you should also consider increase the vertical resolution to quarter scale height. And then if you do that, maybe it's also important to have another kind of tapering at the last few levels so that those tides will be damped at higher altitude. Because if you have a stronger tides, you may have more reflection from the artificial boundary right now.
All right, so two responses to that. First of all, if you look at this slide on the screen right now, and if you look at the red curve, that one tapers to 2 kilometers. I would argue that that's about a quarter of the scale height once you get into the lower thermosphere, where the temperature is now increasing and increasing rapidly towards the top. So I think that requirement is already, if not met, close to being met by this grid, but surely you can adjust that. The other question that you raised is, what do you do near the top? Because if you have a strong tide, you may have reflections. It's not clear to me whether the best way to control that is by coarsening the resolution or by having a suitable damper, say divergence damper, that turns up steeply as you go to the first, to the upper couple of scale heights or something like that. The idea being that tides are divergent waves and gravity waves. They will be strongly damped by a divergence damping, and maybe that's all you need. But I will leave that question to people who know more than I do about the numerics of these things. Does that answer the question, Henley?
Yes, yes. I think, yeah, that's another option. It will be good to apply the sponge layer higher up. Of course, then you kind of wasted a little bit the resources.
Well, essentially, insofar as you cannot impose a radiation boundary condition on models like this, you have to damp things. Mm-hmm. That's life. So in a model like Wacom, I never believe the upper 2 scale heights in any case. So we normally use this model in a credible way to maybe 110 kilometers, and above that, you get what you get. So that's one thing. The other thing is, of course, 2 kilometers is already about a quarter of a scale height. And the third thing is, how do you actually control reflections from the top, which will be unavoidable? I think we will leave it to the software engineering and the numerics people. It may be that a strong divergence damper is all you need. It may be that you also need the additional dissipation implied by a coarsening grid. Okay. Okay. Anything else? Anybody wants to raise your hand?
Yeah, I have a question for Hanli. Have you ever looked at the tides in the SE version to see if they're any better?
You mean the current version of SE?
SE Wacom, yeah. I was just wondering if that would make a difference.
I think we looked at a few years ago. We looked at the tides in the very high resolution Wacom, the SE version, quarter degree, and it seems that the tide there is very, very strong. But that's I think 1/10 of the scale height in the vertical.
Okay, it'll be interesting to see how this develops.
Right. I will mention, Hanli, you may want to work with Peter Lauritsen. I mean, he certainly has been very interactive on trying to get Wacom simulations, standard Wacom simulations that work well in SE. And in fact, I think he has succeeded to a large extent. There were a lot of technical problems that are now overcome. So I would think this SE model, although it's not an official model right now, can be used as a research testbed to look at all of these things.
Yes, I agree. I know Peter has run Wacom 110 levels probably.
Yeah,
but
correct. And
yeah, maybe we should. Yeah, we should take a look at the tides there. Okay.
Anything more on the question of vertical resolution? I mean, I think to summarize the way I look at it, I think going to high resolution in the free troposphere, lower stratosphere is a major breakthrough in terms of our understanding of how the atmosphere works. In the region of the QBO, I mean the lower region of the QBO, but also in the troposphere. I mean, I haven't shown any pictures of that, but I have seen the results for the things at the MJO. It looks a heck of a lot better at the high resolution than it does at the normal resolution. And in fact, you can see why. I mean, insofar as these oscillations, even in the troposphere, are mediated by waves, if you resolve the waves better, you are likely to have a better result. So I think this is a win-win, both for us and for the tropospheric people. And it's something that has been long delayed at NCAR. NCAR has lagged way behind the state of the art in terms of vertical resolution. The emphasis here has always been on horizontal resolution and maybe on the boundary layer. But here we have another whole realm of investigation that opens up because we can go to higher resolution at this free troposphere, lower stratosphere.
Rolando, this is Chuck.
Chuck.
I was just wondering about the time step. WACM-X has a shorter time step. There were some talks this morning showing improved boundary layer with a shorter time step.
Yeah.
For the workhorse model, are they still planning to keep a 30-minute time step? And is there any of our science that might be improved with a shorter time step?
I cannot answer that question because I don't know the answer. Obviously, you need to keep that in mind. Parameterizations, including the boundary layer parameterizations, unfortunately appear to be sensitive to time step. How that will be adjusted, I don't pretend to know, but I think definitely it needs to be addressed. Right now, all of these studies we have been doing with this task team have been in the context of the FB model as it exists right now, including the time step. Okay. I presume that answered your question. I cannot see you, but presumably you are nodding happily now.
Yeah, I'm nodding happily.
All right, good. Anything else on resolution? Because the last topic I wanted to bring up is what does all of this imply for the future of WACM?
So I just have one comment, Rolando. This is
Yes.
Doug.
Yes.
I think this is great that we're going to higher resolution in the UTLS region for numerous reasons from a chemistry standpoint. One is to look at heterogeneous chemistry, influence of gravity waves, and also to support aircraft missions like ACLIP. And I think we're going in the right direction here, and I'm really pleased to see that this could be the future of WACM. So that's my.
It's 2 o'clock.
Okay, hang on a second here. I have a few other topics to bring up. So yeah, I agree, Doug. I mean, I think we are all on the same page on that. I mean, the benefits of high resolution are not just the QBO. They are the QBO, they are tropospheric circulation like the MJO, and they are also in the realm of the simulation of the troposphere, I mean the tropopause, and also in the simulation of chemical species in the UTLS. So I think it's a win across the board, and I think it's high time that NCAR address these things. And I think finally we are doing that. So yes, I agree. Okay. All right, so some topics that we need, some of these are somewhat housekeeping topics, but I think are important. WACM coach, I mean, whole atmosphere working group co-chairs. I've been doing this for 2 years, and you know, I am not even supposed to be working full time, and I find that I want to get some papers written, and I think it's time for me to step down. I am thinking that a good time to do that is sometime early this fall when the task team work is done, and I can fold that into what the whole atmosphere working group has been doing. So I asked for volunteers, for people who might want to be co-chairs, internal co-chairs for the whole atmosphere working group. I have one volunteer. I won't mention names right now. And again, I would encourage you to think about volunteering or asking some of your colleagues, especially the younger colleagues, to volunteer for that. I will be glad to do whatever I can in transferring what knowledge I have acquired in the last 2 years, which have really been educational. So, that's one thing about being co-chair of this thing. It's a pain in the behind, but it's also fairly educational. So that I think is worthwhile. And then Jessica New is our external co-chair. I don't know if she's at this meeting, but in any event, my recommendation would be to ask her whether she wants to re-up. If she doesn't, of course, we need nominations for an external co-chair as well. So both her term and mine end this fall, as I noted. So I don't know
I'm here,
if you have
Rolando.
this, but just so you know, Jessica is here.
Yeah. Yeah, I'm happy to do either. I wouldn't mind extending as co-chair, but I also, if someone is keen to do it, I'm more than happy to move on and have someone else take over.
We are always happy to have people re-up, especially people who are using the model, who are strongly involved in it, who are, leaders in their field. So, a good external co-chair is not hard to find. The only difficulty is that sometimes they say, well, I've done this enough, it's time for somebody else to do it. But if you are willing to consider it, I think we can probably consider that closed, that part of the thing closed. But we still need an internal co-chair. Okay, so you guys need to be thinking about that. Any other comments on this?
Yeah, just traditionally we've rotated. We started with DAM and then ACOM, and then our next co-chair was Hanli and HAO, and then Andrew and CGD, and then back to you and ACOM. So by that logic, it's HAO's turn, but I don't know if we want to continue with that or not.
Yeah, I thought you were saying that you were going to volunteer in spite of that, but I guess you're not.
I'm the liaison.
Seriously speaking, I mean, that has been the tradition to rotate the internal co-chairmanship amongst the 3 divisions. And, another possibility is we could have 2 internal co-chairs. A number of the other groups do it. And that will lessen the work that is required, because the internal co-chair does have to attend all of the co-chairs meetings, and those are usually once a week. So, we could share that burden. So, think about it. I mean, I'm going, in the future, I'm going to be talking to people at HAO, ACOM, and so on, and see what we can come up with a succession. There is no immediate hurry. As I say, I am more than willing to stay through September or even a little bit later until the work of the task team is completed and things are in good shape to be handed off to the next person. But I do not intend to serve another full term. Okay, what else? Any other comments on that? Okay, no comments. Oops. Let's see. Okay, did that. All right, so the future of WCAG at Anchor. I mean, we are doing so great that you have to ask, why am I worried about the future of WCAG at Anchor? And let me tell you why. I think the most important thing is that once a workhorse model is developed, WACOM itself would no longer be an integral part of any future CMIP exercises, CMIP work. I mean, that workhorse model, as we said, will have a top at 80 kilometers, 5 vertical resolution in the middle stratosphere, good chemical schemes. All of that is wonderful, but it is not a middle atmosphere model. It is not suitable for research in the mesosphere and the thermosphere, and it requires that future versions of WACOM be built on that model. We have already discussed all of that, okay? Now, my concern is the last bullet point there, which is, will WACOM be marginalized within the institution? Because number one, it is no longer essential to CMIP. So, maybe we don't have a strong CGD motivation for the importance of WACOM. And also because, in my estimation, much of the work being done at ACOM doesn't care about the mesosphere, let alone the thermosphere. Okay, so my question is, will WACOM remain relevant in the institution? Obviously, it's relevant to us, but will it be relevant, and therefore will it be able to garner resources from the institution if it becomes of no importance to at least two labs that I can think of, AECOM and CGD. I think it will always be important to HAO because I cannot do space weather otherwise. So that's my question. Are we in danger of WACOM becoming less than essential to the work of NCAR laboratories? And like I said, I think in the case of HAO, the answer to that would be no. But in the case of the other two labs, CGD and AECOM, I am not so sure. So I wanted to throw that out there for discussion. I know that I may sound like a bit of a radical idea, but I think you have to be thinking about that. Certainly the story of WACOM at AECOM is that AECOM has paid lip service, but they have not supported us very strongly. Okay, in particular, they have not supported the renewal of personnel to carry on the work with the model. And anyway, take that into account, right? Any comments? All right, well, I see you are speechless about this. And
all right, I'll weigh in.
Okay.
I think that WACOM will still have a lot of interest in anyone interested in stratospheric composition. I don't think you're going to get anything like their proper deep branch of the residual circulation. You're not going to get the water vapor up high enough to be photolized. So your Hawks will be wrong in the high latitudes. Your CFCs will be wrong out there. Everything else that requires that you actually get, you know, the transport up into the MLT region that shortens the lifetime and that sort of thing. That you're not going to get your CO right. Maybe, I mean, maybe you can get all this right if you start still running WACOM in the work. You still need to run WACOM in order to provide boundary conditions for the workhorse model. You know, so I still think there's going to be a strong need for WACOM, and that, of course, you know, its niche is still going to be that it's the base of space weather model, one of the few most successful space weather models that goes from the surface all the way up to 700 kilometers with chemistry. So I still think we have our niche. I still think there'll be a lot of people interested in using WACOM. I do think also that, you know, we haven't talked about it very much, but there's probably half the use of WACOM using specified dynamics. So, you know, the discussions of the grids are all well and good, but really we're going to be running this model on the merit grid for a long time. So, you know, in our current configuration, I think, for SD WACOM. So I still think that there's a strong need to keep WACOM around, that it won't be supplanted by a combination of WACOM and extended CAM and WACOM X. People really just can't afford to run WACOM X.
Okay, well, I mean, you are more sanguine about it than I am. I mean, yeah. I agree with the points you made about getting the chemistry and circulation in the mesosphere correct, but I think a lot of people don't care. I mean, for a lot of people, the atmosphere ends at 100 hectopascals. For some other, it ends around 1 hectopascals. And, you know.
Yeah, but it's more the composition of the high latitudes will be right without the proper circulation.
Well, right. But, you know.
Even in the stratosphere, so where they do care.
I've been around enough of these co-chairs meetings to know how people think. And that's where my concern comes from. From that and the fact that by straddling 3 divisions, we end up not being essential to any of them. And I think the workhorse model is going to accentuate that trend.
Hey, Rolando, this is Cora. To what extent does NCAR worry about the external community? I mean, even if there aren't a lot of AECOM people who look at the MLT region, what about university and other folks who do? So we need the model.
Okay.
Yeah, I agree. I mean, in theory, it's supposed to be, this is Jessica, it's supposed to be the community climate model, right? So I guess that is an interesting question is, do the resources at NCAR depend more strongly on NCAR interests or on community interests?
Well, I think it's both, right? And I think that's why we provide input to GoCon and people are asked in sessions like this one. And I guess it would be curious what the chemistry working group is thinking, whether they would think that the workhorse model is enough or whether they would actually continue using Wacom. I think there would be, you know, for things like geoengineering and other chemistry, climate interactions, would the workhorse, the low top model be enough, or would you still want to be using Wacom?
Yeah, if I may quickly answer both questions. The last point that Yaga made is an excellent one. Luisa can comment now, or because we are actually running out of time here, right? We are supposed to stop at what? At 2:30, I think. So we have another 15 minutes or so. Maybe that question is best taken up during the second half of this session, which will be led by Luisa as co-chair for the climate chemistry group. But it is a good point. Would people working on atmospheric chemistry at NCAR care about anything about the stratopause? The question, the answer is not clear to me, so we have to bear that in mind. Now, to go to Cora's question, I know that there is a number of people in the community who can and want to use a model that models the mesosphere, lower thermosphere properly. And I think that is a good argument to bring up NCAR. I am just telling you what the realities are as I see them. Okay, essentially, in 3 years, a lot of the people who have been supporting Wacom or have been working on Wacom at AECOM will disappear one way or the other. And there's absolutely no plans to replace any of us. So again, this is what I say, you know, because we straddle the divisions, we end up not being necessarily the main concern of any of them. And this is, I think, the main threat to the survival of Wacom. I think at NCAR, the middle atmosphere is viewed as a fringe field. Okay, so that's what I wanted to bring this up. You know, we can argue the point one way or another, but that's the reality as I see it. And if somebody disagrees, I would love to hear the argument. Okay. So I think this is about all I had to say. I am going to stop sharing here. And again, if I can figure out how to do this. How do I stop sharing? Let's see. Well, I don't seem to be getting anything that allows me to stop sharing. So, oh, here we go. Stop share. All right. So now I can see all of you now. And I will just ask you whether you have any other comments that you want to make. If not, I mean, we are almost at the end of the session, or the allotted time for the session anyway. So we can take a little bit longer break before we convene for the second half, which begins, when does it begin? Hang on a second, let me pull up my agenda here.
3 o'clock.
We begin at 3 o'clock and we go until 4:30 for the second half of this joint session. And again, that will be Luisa who will be leading that. Luisa, since we have another 10 minutes or so, if you care to make any comments on how you see the relevance of a middle atmosphere model for the kind of chemistry work that you or people in your group are doing, this possibly will be a good time to bring this up.
Not sure I have much to say, but I might ask Simone and Mike if they want to say anything about the applications for geoengineering, since you brought that up. There's certainly, you know, a need to have the stratosphere properly resolved for tropospheric chemistry applications, but there's a lot more in chemistry climate interactions that where Wacom would be applicable.
I can start. I did actually, it is really the question which we haven't answered yet. will this model be appropriate for those studies? I think we have to see, once it's done, we have to compare how well it compares to the current WACM model, because, you know, without having the model, we cannot test it. So in that regard, I don't know.
Okay, thanks. Yeah, I think a lot of the future of WACM will depend on how that question comes out on the chemistry side. Because I think if MOEV guys are happy with a lower top model, then I think that's maybe where the energy will be focused. That's where the staff is, right?
Mm-hmm.
Yeah.
Yeah, that's certainly more the focus in ACOM. And so that certainly seems to be where there'll be a lot of support. But I think Cora brought up a good point of we do need to support the community. And we tried to have we sent out a survey after the March meeting and tried to get, feedback on various things, but maybe a community poll of how would you like to use the models and what do you need a high top model for, or do you need one? Some very specific questions so that we can, then we have those numbers. Neverland.
Actually, we do have those numbers.
Okay.
Off the top of my head, of the users of WACM, about 50% were doing middle atmosphere studies, that means mesosphere and above, and the other half were doing mostly stratosphere and below. So the demand is there. I mean, at least amongst the people who responded to the poll. What is not there is internal support at NCAR. Like I say, because WACM was started in prehistory, about 20 years ago, as a three-division, multi-divisional effort, it has not received strong support from any of the divisions, other than for the initial starting money, which came from Tinky Lin, if I recall. So that's a long time ago. And once we are gone, meaning I, myself, Dan, and for that matter, Kinnison, all of this of the work was going to support WACM in ACOM is going to be gone. I have had this discussion with a lot of people at ACOM, including Guy, and I have not gotten, other than yes, I have not gotten any commitment to say we need to renew ourselves. So insofar as there is a future for WACM at NCAR, it's not going to be in ACOM. I mean, that's my view, and I could be wrong, but that's my view right now. We'll see who the new director is when they come in, and so far I haven't heard anything that makes me very sanguine about it. Okay, so that's my concern going into the future, which you young people, or younger people who are working with WACM should be keeping in mind. Okay.
Rolando, I have a
Henley
question. Yeah. So because now there's this new development of Musica and SEMA, I'm not sure what's the plan at ACOM to kind of bring the current WACM chemistry package or the expertise into a Musica. What's the future development there with regard to the middle atmosphere chemistry?
Yeah, I think Luisa or Dan can answer that.
There is a working group. We're just starting to form working groups as part of Musica, and there is one on the whole atmosphere. So it's definitely intended to be part of it.
Yeah. I mean, Musica has always struck me as an unfunded mandate, but maybe you guys know something I don't. Yeah. I mean, if you don't have the people to work on these things, I don't see how you can develop any more. There was another question.
On the question of whether we need a WACM or a so-called high top model for geoengineering or volcanoes, I think it depends on what the low top model is. If the low top model moves up to 80 kilometers, that might be workable for geoengineering and volcanoes, especially if it has interactive chemistry. But if it stays at 45 kilometers, it's inferior.
Right, right. I mean, I would agree that the model with a top at 80 kilometers and resolution that does not degrade radically towards the top boundary might in fact be suitable for that kind of study. I mean, it remains to be seen, like suitable comparisons with a true high top model. But in a sense, we're trying to keep CGD honest, not letting them to reduce resolution so much that the mesosphere becomes irrelevant. We may be shooting ourselves in the foot in the sense that a workhorse model may be good enough to do a lot of the work for the stratosphere and even lower mesosphere, on which things like geoengineering and volcanoes depend. So, I mean, that's true. Yeah, I mean, the main problem I see is the loss of dynamical insight and expertise into these things. Right? If some of us have not insisted that you need to go to higher resolution to get at some of these physical phenomena above 100 hectopascals, we will still be sailing merrily along, you know. And you know, once we are gone, there's nobody who is going to advocate for those things. So again, you guys, young people, have to think about how you want to deal with it. Okay, anything else?
Yeah, I have a question about the long run. Yesterday from the paleoclimate working group, I heard that Vacan 6 Mar FV 2 multiply 1 had a run in this past 1,000 years. And what's your plan? Any further collaboration with paleoclimate working group to run longer time period?
Yeah. I mean, we do have the 2-degree model, and the 2-degree model is roughly a factor of 8 cheaper than the 1-degree model. I mean, horizontal resolution is much more costly than vertical resolution because it scales essentially almost as the cube of the increase in resolution, because a factor of 4, 2 by 2 for the space, and then you have to also deal with a reduced time step to meet the CFL criterion. So it's very expensive. So that's why we went to a 2-degree model. I am myself using that for studies of the last millennium. Okay, the one thing that we have not really looked at in the context of this model is whether we can get a decent QBO by suitable tuning. This is another problem with WACM. We just don't have the personnel to cover all of the bases. I mean, obviously this ought to be being done, but who's gonna do it? And so we do what we can. But to answer your question specifically, yes, there's a 2-degree model. It is much less expensive to run than the 1-degree. And I think it's the right model to use for very long-term integrations, things in the multi-century to millennium type of simulations.
So there's no plans for this 1-degree model to run the long period? For the last
well, I mean, you can make all the plans you want, but if you do not have the computing resources, the answer is no. And right now, we do not have the computing resources.
Okay, thank you.
Yeah, you're welcome. And I mean, what I would like to say is, in principle, it can be done. But in practice, we just don't have the resources to do it.
Mm-hmm.
Okay. Shall we sign off if there is no other questions? Yeah, I should have had a glass of water, you know, after more than an hour talking. My throat is scratchy. But anyway, thank you, everybody. I think it's been an interesting discussion. I think people, you know, contributed well. I am happy to see that there is an interest in this, and we will see what we can take it from here. And beyond that, we have, I think, a half-hour break, and at what do we say, 3 o'clock, we reconvene here in your Zoom box.
Do we use the same Zoom link when we reconvene?
Yes. Yeah, you can
Yeah,
just leave
meeting
it
goes
open.
till,
Just leave it open. It's the same
Yeah,
one.
you can leave it open and come back in a half hour.
Okay.
You know, probably you want to close the camera and go in, you know, but other than that, yes, I think that's the way to do it. So thank you all, and we will see you then in at 3 o'clock, where Luisa will take over. Thank goodness. Okay, thank you all. Bye-bye.
Bye, thank you.
Bye.
Hi, everyone. I guess we could, well, wait a couple more minutes. One more minute. Looks like everybody's still here, but I don't know if they're all still on break. It's getting hot here. I don't have air conditioning and
Yeah, in Laramie is still cold. we are colder than Boulder, yeah.
Oh, really?
Yeah, a few degrees colder.
Oh, wow. Yeah,
Especially at night, the early morning is very cold still.
Oh, yeah. Well, I do not plan to talk for 90 minutes. And so I hope that people will contribute and ask questions and help guide what we talk about. I have a couple slides and we can go back through the presentation I showed yesterday if people want to hear about things in more detail. And if anybody has anything they would like to share about the research they're doing or development or any other activities that they'd like to share with the group, we'd love to hear about them. So I'll get started just and show these, our outline of topics that we had thought that we've been working on and that are going into the next couple of versions of the model and maybe and longer term development as well. So the biggest things that we've been working on over the past few months are the aerosols, and there's been a lot of discussion about them at the past few meetings. If anybody would like to hear more about them, we'd be happy to go over the recent changes and what we're planning. And with the newest thing is the incorporation of MAM5 to take care of the stratospheric sulfate aerosol, as well as Mosaic that we've been talking about for quite some time, but I think it's really quite close to being released.
Louisa, somebody asked if you can go on full screen.
Okay.
Thanks.
Yeah, lots of chat.
That works.
Okay. Oh, there's chat. So do you want me to go through any of these slides? Do people have questions? One thing we haven't talked about is karma. We don't really have anybody at NCAR working actively on that, but that's certainly something we'd like to include in the future.
Actually, that's not quite correct.
Sorry.
Because Mike Mills and I starting
that's right.
actually look into integrating the latest version of Karma that is currently in CSM, but not in the latest version, into the latest CSM2 version. So that's in development, I would say, and it will take a while.
Yeah.
But at least we're starting to look into it because, as people know, Karma is a sectional model, and at the moment, we do not have a Karma version that works actually for the full troposphere and stratosphere and replaces MAM fully. And I mean, I'm happy if Mike wants to add something about that, or if other people have any questions. But at this stage, we're just starting, so it's still a long way before it will work.
Yeah, that's basically it.
And I have a question after Mike is done.
Well, I was just going to say, as Simone said, we're looking at ways to replace MAM with Karma as an option. Okay, that's all.
Good. Rolando?
Yeah, the question was, I mean, with Karma, I think a number of us have used it more than once. Certainly the work I have done with Chuck, and Chuck continues to do work with it. But I mean, presumably this will continue to be an optional aerosol parameterization for Wacom or CamCam or both, right? I mean, my impression is that in general, it is too expensive to run as your standard parameterization unless you need it for a specific purpose. Is
Yeah,
that correct?
Yeah, I mean, you can see it more like if done properly as a benchmark version to evaluate the MEM model, we assume that a sectional model is better and represents the aerosols better than MEM. If you can run them, maybe even probably not parallel, but it, you know, specify dynamics or so, side by side, you can hopefully learn something also for the current model version. Certainly, it's way too expensive for climate models, and it's not planned to have any Karma model version at any time in climate runs. But what we are really interested in is the geoengineering part and the representation of volcanoes. So if that changes answers, then it's important to know. And so that's why we think it's really important to have that model. It's also for supporting eventually like the aircraft campaigns, ACLIP. But you know, we'll have to see where we are at the time an ACLIP is happening.
Just a question: is the Karma was in the CSM1, right? Is that currently not in the CSM2, or is that
it's in there in the same way it was in CSM1, but it doesn't interact with radiation. And when you move to Cam 5 and Cam 6 physics, which we're doing for the first time in Wacom in CSM2, the aerosols interact with the clouds. So that's all set up to work with MAM. So it needs to be redone to work with Karma.
Okay.
That's not totally correct. I mean, what's currently there will interact with radiation, but the more complex mixed aerosols that change composition don't have a way to interact with radiation without moving forward to some new things that Peng Fei and I have been working on. And I have been using this with, you know, sort of 15-year long simulations for nuclear war studies and the KPG impact studies. And we just got an NSF grant funded to extend those KPG studies. So we will be continuing to use the Karma model and different flavors of the Karma model. So not necessarily the same version of Karma that Simone and Mike are working on, which is Peng Fei's aerosol model that's a complete replacement for MAM. What I've been doing is more of a smoke model that layers on top of MAM.
Yeah, and we certainly engage Chuck in our work as well, to mention that.
So Louisa?
Yeah.
This is Joyce Penner. I had to miss yesterday. Could you just do a short review?
Yes. So there are a number of developments that are not, they're very close to being in the model, but the model's not fully tuned with all of these aerosol changes. So we are going to do that over the next few months and be able to release them in CESM 2.3. And so they include Mosaic, which allows the simulation of ammonium and nitrate, handling the gas aerosol exchange. MAM5, some aerosol wet scavenging improvements in convective clouds, and the brown carbon radiation effects. that Hunter Brown put in, and also a new dust emissions scheme. So the nitrate aerosols we've heard about for several past working group meetings, but is working with MAM4 in CESM2, and Zheng Liu with Xiaohong has done this impressive work, and it has a paper in review showing, for example, the impact of the direct radiative effect of nitrates over the past decades. And this new MAM5 is to account for the, in CAM 6, we changed the size and standard deviation size range for the coarse mode to treat the sulfate aerosols after volcanoes better, but had inadvertently affected the dust and sea salt. So we're adding a 5th mode to just handle the stratospheric coarse sulfate. And Xiaohong's group and Mike and Simone have been testing that, and it looks great. It does stratospheric aerosol just right. And then we have the improvement in aerosol scavenging. If you have questions, maybe Xiaohong and Yongpeng can talk more about that, but it improves the aerosol distribution in the upper troposphere, so that matches observations for black carbon and sea salt. And Natalie's group has a new dust aerosol scheme, or well, they're putting in the Jasper Koch's scheme that, and with the going back to the coarse mode distribution, size distribution that we had in CAM 5, they've found good agreement with observations, improved over the previous scheme. And so that will also be going in at the same time. And one thing nice about this is it will not require a soil erodibility map, so we'll be able to use it for any resolution, for variable resolution, whatever, without having to regrid the soil maps. So that was that in a nutshell.
Yeah, so in addition, the wet scavenging is already in the CAM sets that we are going to release. So that part from Yunpen will be available in the next release. The other will be still tested. And then there's a comment, Louisa, in the chat. Should we address that?
Yes, sorry, I can't see them.
No,
so
I can.
well.
I keep track of it.
Okay, good. Let me know.
Yeah, so there's from Nicolas, I think, a postdoc in Chile working with dust aerosols. I'm under the impression that MAM5 cannot represent dust aerosols larger than 10 microns. I would like to represent atmospheric transport of aerosols with up to 40 microns. Is that possible? I guess that may be for Xiaohong.
Yeah, so we tested that. We have the dust emission over the dust size larger than 10 micron. But since the model just basically, the dust is, for the big size dust, they settling pretty fast. So they basically, the dust over the oversized 10 micrometer can be important maybe only regionally over the dust source region. Once it's transported, this very large size dust can sediment out pretty quickly from the atmosphere. So yeah, so you can test, and so we my group Ziming, and he did something like adding the supercoarse dust in the model, but the model basically the dust is settling pretty quick because these big size particles. I don't know if so you can, it's worth testing, but yeah. So but the model right now is the observation did show some cosmos dust like this, but the observation by model still have yeah, I haven't treated that, but because maybe there's some mechanism that the model hasn't included account for.
Great.
Yeah.
Any other comments, questions? So some of the longer term developments, Maria Valmartin has put in soil NO, ammonia, and N2O emissions into the land model. So hopefully that'll be available in coming versions for people to use. Douglas Hamilton with Natalie has a soluble iron scheme looking at geochemical responses. So if there's interest in that, we can include that in the model. We're still working on TUV. I've been doing a little work looking at simpler chemistry. Becky Schwantes has been putting in more detailed chemistry. And our postdoc Wenfu has been working on really looking at coupling the fire emissions from CLM into CamChem. So there are a number of, and I also just talked with Alex Gunther, and hopefully we will work soon on getting Megan 3 into CLM so that we can use the latest version of biogenic emissions from that. I had done, might as well show you what I've done with the simpler chemistry. Nobody has other comments. So the workhorse model that we've been hearing about, it would be nice to have a chemistry scheme that's not as expensive as Wacom for climate studies. So with fewer levels, it'll be cheaper, but also simpler chemistry. But the current CAM chemistry with specified oxidants is really not adequate for doing a lot of, you can't properly simulate secondary organic aerosols, and you cannot calculate nitrate and ammonium aerosols without having NOx chemistry. So this is just a summary of the number of species. So we currently have 230 with, or 220 in CamChem, 187 transported. And Mosaic would add another 15 species to that. So it would be nice to have something less. So the middle atmosphere mechanism has the detailed stratospheric chemistry and just methane chemistry in the troposphere, but that's not quite enough. We'll need something a little bit more. So I've been looking at maybe going back to the Mozart 2 scheme, which is essentially what the GFDL Earth system model is using now. So that's 63 species in the troposphere, and we'd add to it our 70 species from the stratosphere. And I did some quick runs with that, and it looks essentially the same as for surface ozone and also for AOD and sulfate matches quite well. So I think that's a good possibility, but it's still quite a few species. There's another mechanism used by the UK Earth system model, which has a total of 84 species for the troposphere and stratosphere. So I was thinking about looking at incorporating at least some of that chemistry, further reducing the isoprene oxidation and that sort of thing. So I don't know if anybody has any thoughts on what level of complexity is needed, or how other suggestions for benchmarks to make sure that a cheaper chemistry is still giving reasonable results. I'd be happy to discuss that. Hear any opinions?
There's a question first from Stephanie Falk. Are brominated chlorinated VSLS accounted for in the chemistry?
No, no. So we don't have any of that yet. So there's a Doug and Alfonso's group in Spain have been working hard on that. So that's sort of a separate mechanism, and whether some of that needs to be included in the simpler mechanism is a good question.
Hello, Louisa. This is Doug.
Hi.
I talked to Alfonso's group actually today, and I asked them what the status was because I did the initial work to kind of get it going, and they're doing some final tunings and stuff. And so it's probably another month or so out before we're going to really have that VSL bromine and iodine chemistry for the troposphere in line. So I think at that point, then we can maybe talk to Alfonso and others to see if we can have a more simplified version of that and cut down on the costs. Okay.
There are some comments to nitrogen emission, ammonia emissions and so, but maybe we address those later when we talk about that topic, right? Luisa, you're muted. Sorry.
Sorry, I took some water, drank some water. So do Maria and Peter want to say anything? We can go back to ammonia, soil emissions. Thanks.
Yeah, I'm here. This is Peter. So,
hi.
Hi, Louisa. Hi, everyone. Yeah, so we've been working with CLM to put agricultural ammonia emissions into the CLM model. So interfaces with the crop model. It does not do NOx like Maria's scheme does, but we do ammonia both from manure applications and from synthetic fertilizer. What can I say? There's a paper published in GMD now by Julius Vera, who describes a scheme, and we have one in progress comparing the atmospheric ammonia to measurements. And so that should be released with the newest version of the CLM.
Okay, great. Yeah, sorry, I forgot to catch up with you on where that stood. And that's what Maria said. Good. Any more thoughts about soil, ocean emissions, other topics? Back.
Louisa, this is Doug again. Just on the status of emissions, I know for ACLIP, which has been moved to 2021, July and August, Simone, and maybe this is a question for Simone, we have done some work where we've used the ECMWF CAM's anthropogenic emissions. Will we be able to get those real time during the mission period?
I mean the anthropogenic CAMS emission?
Yes.
So currently, actually, these emissions go from 2000 to 2019, but then we also got a new version from CLEAR from 2020, which we added. And my understanding is it's really a scaling, a trend that is applied to the emissions. So, I mean, I suppose those 2020 emissions, right, for the whole year were provided already by the beginning of 2020, even though we don't know. So it doesn't include any changes due to COVID or anything like that. That's the first thing. So the question is really what will be provided. If they provide another set of emission for 2021, it's probably the same way. They will scale in some way the emissions. So that's probably what will be there. I don't think we have anything that is like the fire emissions, which is different. For the fire emissions, we use our tools to derive fin or QFIT emissions, basically, right, that day from the information we get from satellite or whatever. So that's different.
Okay. For everybody, one of the things that's happening this summer is we're going to have a dry run again of the Asian monsoon season. And we're going to be forecasting with WACM and the GEOS assimilation model and ECMWF. One of the things, Simone, would be really nice is not to have, or to have the emissions that are not reduced due to COVID for that season. And so I don't know if we need to talk to Claire Grenier or whoever is part of that to get that update.
You want the emission with or without the reduction?
We would like to have whatever's current in the atmosphere. So not extrapolated from a non-COVID season.
Yeah, I think that's maybe another discussion. I'm not sure how much it fits in here, the production and current work that is going on developing a mission for the COVID period. There are different approaches. I don't know. I leave it up to Luisa to see.
Yeah, I think there are a number of activities. There's a group in the UK who's coming up with something to do some IPCC type simulations. So that's just a scaling starting from IPCC. And then there are other groups that have been doing data assimilation. So there may be more realistic of actually what actually happened. The IPCC ones are scaling based on changes in observed. But
well, we can take this offline then.
Yeah, so I think there are, but I think if the community is interested in doing COVID simulations, impacts simulations, it's good to coordinate and make sure we can share emissions files and not duplicate efforts. But people who are interested, we could certainly try to coordinate some forum to discuss that.
I just wanted to say that Claire said she would make the emissions available by next month, July. So
of what?
Working for CamCam.
Okay, scaled based on
updated emissions.
Yeah.
For 2019 and 2020.
Oh, okay.
Yeah, I would like to point out that the ComSats and so on usually are not using really emissions that go to present day. But we do develop wikis. We do have a wiki for CamCam, and we will develop a wiki for Musica. Maybe Luisa will talk about it later, to point people to those new emissions so you can actually use those. That's something we are planning.
Yes. And eventually, hopefully, they'll be able to be regridded online, and so you'll be able to use them for whatever grid you'd like.
So Luisa, and before we move, so you talk about different option of the chemical mechanism. Do you have some ideas? What's we care about, like computational cost also? Like
well, right. So that's the whole reason to do it, is to make it cheaper so that the climate folks
like
will be.
You talk about Mozart 4, Mozart 2, or so these. How do you have an idea for the different how they compare?
So so this run, the standard CamCam with about 200 species. I think there were some extra tracers. That's why it was a larger number. Was 6,000 core hours.
Oh.
And when we dropped to 154 species, that's down to 4,700. Still not very cheap for the CAM people. But it's a reduction. So if there's a need to have, so T4 is this Mozart 2. If that's still too expensive for people, we can work on making, further shrinking the tropospheric chemistry. I asked Doug if we could simplify the stratospheric chemistry, and he told me I could take out odd fluorine. So I did that, but there's still a few species there. And And calculating the stratospheric ozone and the ozone hole is really important for the climate. So it seems important to leave in. Not take shortcuts there. I suppose there will still be a workhorse CAM model that reads specified oxidants for people who really want something simpler, or they're not interested in simulating SOA and nitrate. But I think for state-of-the-art climate model, it's important to have those in there. Other thoughts? Does anyone have an idea of how cheap should this be?
There's a comment. Stephanie Fall, do you want to say that yourself? I can read it, but why not?
Okay, I can also say it. So I was wondering, when you're talking about simplifying the tropospheric chemistry, how well are you aiming to capture the surface ozone field?
Well, yeah, I didn't get very far in actually comparing this to OBS, but that is certainly one of the goals. That would be one of the metrics. So this plot is the surface ozone zonal average, and it's essentially the same, but certainly to look at it in more detail compared to observations is the next step. And so I'd hope that that would be reproduced. That would be one of the things we need to reproduce.
And there's a comment by Susan Solomon. Do you want to tell us about that?
Oh, taking odd fluorine out of the stratosphere was okay.
Oh, okay, okay. It was about.
Yeah, as long unless you want to look at newer CFC replacements, then. But so I think we should keep in the model a library of mechanisms depending on the questions you want to ask. But it is good to have some standard ones that we verify and scientifically validate for people to use. And then I see Dan asked, are we exploring machine learning approaches? There certainly are groups trying to come up with simpler chemistry based on machine learning. And if somebody who knows anything about that would like to say anything, that would be great. I don't have, does seem like something we ought to consider.
There's another comment about the fire emission plume rise.
Yes, so Maria, yes, we are investigating doing more with plume rise. Wenfu is exploring various ways of doing it. At the moment, if CLM calculates fires, then we use the scheme we put on based on Maria's work on the Miser plume heights per PFT. But if we're not using CLM fire, then we have to specify in the emissions files what the plume rise is. So I think Wenfu is going to start with exploring what the impacts of different plume rise compared to these recent FireX and WECAN experiments. And maybe even look at doing what is done in WRF-Chem, like the free tests plume rise model. All that work is all just starting. So if anyone has ideas, suggestions, certainly welcome them. Other questions, comments? In March, we talked a little bit about a couple ocean atmospheric coupling things. Xiaohong is working on marine organic aerosols. We have a, Xiuan Wang has an online ocean emission module that I think will be released in 2.2 for doing DMS and organics from the ocean that's coupled to sea surface temperature and the model, but not the full ocean model. So it's an improvement from what we've been doing. Oh yes, and Wenfu is also testing the impact of fire diurnal cycle. So hopefully we'll have more results from that soon. We have been, well, I showed results from Musica with the variable resolution with the spectral element, and CSLAM. We'll also have the capability of doing higher horizontal resolution for the whole globe without being as expensive. We have a new way of doing the nudging to meteorology. So it's on the model levels, which seems to perform better than when we would nudge to we would use the model levels from, say, MERA 2. And the model CESM was tuned to the specific model levels for clouds and things. And so using different model levels had some unintended impacts. So the CESM 2.2 release will have the nameless and parameters for this new nudging scheme.
Maybe I can say something more about that. So people are used to check out the model. They are usually getting these FCSD COMSAT for chemistry, so specified dynamics. That's on the levels of MERA or GEOS5. And yeah, Luisa had a slide on that. Now we are calling the new COMSAT to distinguish between the old ones, FC nudged. So because they are specified dynamics in a way, but really what we are doing is nudging the model or the tendency to a certain state with various ways, and there are much more options and a lot to explore. The COMSATs are there so people do have something to start off, and we explored that a very tight nudging, both the old and the new way, can really mess up the dynamics of the model, the mixing. And so at the moment, the default is something like a 50-hour time nudging number. But of course, people can go a little tighter. But there's also a group right now looking at this, Nick and Patrick, working mostly on exploring how can we actually nudge in a way that it may be tighter in the troposphere, where we need maybe the meteorology to be represented well, especially for forecasting. But it has to be a little looser in the upper, maybe in the stratosphere, for representing the model there and not introducing nudging. And so Nick and Patrick or whoever, feel free to add to this. This is just something that we are working on, and hopefully find some solutions in how to improve that in the future. Nick or Patrick, does anybody want to add something to that?
I would just say that there's room for improvement, and we're working on closing that gap. So,
yeah.
Yeah.
So this is Jeff Anderson. I just want to remind you that you have a comprehensive state-of-the-art data assimilation capability too. So you don't have to nudge to someone else's reanalyses. You can use the observations effectively, and you can do that just for the meteorological variables, or you can also do it for the chemistry variables, and people like Ben Gobert have been doing a lot of work on that. But the data assimilation capability for the dynamics is, I think, really a much better way to go than nudging at this point. In addition, we've generated some long reanalyses, and Kevin Rader will talk about those at the new working group meeting in the morning. Some of those reanalyses, they're from CAM, and some of them you might be able to nudge to them even without going to full data assimilation of your own. So there's a lot of options available here that will get rid of a lot of these challenges with going to a foreign reanalysis.
And that's very good to know. I mean, we know that this is going on, and at this point, I mean, one reason we really didn't have those available, I guess, and if they are available, it would be great to test them. The other question: are you running? I mean, I suppose you're running forecast as well. Is that correct?
So we have been running essentially a reanalysis system, which involves doing 6-hour forecasts. We have not done longer term forecasts, but again, Kevin will point out that that's trivial to do. So the analyzed ensemble initial conditions are available. And we have the capability to do this with CAM, with WACM, with WACM-X, and with any of the 3 proposed dynamical cores right now. So the SE, the FE, and MPAS, we can do any of those 3. There's no doubt that working with chemistry with some of those would be something that hasn't been done yet, but mechanistically it's available now.
Yeah, I think that the problem that we have is with the transport, and that's what they're kind of looking on. I don't know, with the data assimilation approach, would that be an improvement on how to reconcile the difficulties of doing transport calculations?
So we'd probably have to talk a little bit more in detail, but essentially the data assimilation is using the available observations, either, and let's start with just saying of the meteorology, the same ones that are used by NCEP or ECMWF, and they are constraining the CAM model to look like an analysis that you would get by working off of a reanalysis at any one of those operational centers. But the process is consistent with the dynamics of your model, and it will be the advection that you would get that makes CAM look consistent with the observations.
Yes, sorry, that might be good for a comparison between what we're looking at and it's like a frame of reference, I guess.
Jeffrey, do you have to run an ensemble every time that you do that, though, going forward, or?
Yeah, so the methods we do, you need an ensemble, but they are, the cost is what it is. Again, we definitely need Ben Gobert involved in this conversation, who's been working on this stuff for years and understands the chemistry issues better than I do, but also understands the data assimilation issues. But the expertise and the tools are available at NCAR at a minimum to explore what going these directions would do for you.
Yeah, if we think about something like ACLIP, right? We do right now use the analysis that are provided by Mera GS5 or something, because we can just download the data in 1 hour and start running our forecast. And then we can actually provide like up to 10 days. And the question is, how practical is that, especially if you think about that this is a model we need for the middle, I mean, at least in the stratosphere as well, since it's focusing on the UTLS region.
So any of the things you're describing are possible, whether they are possible within your resource limits and whether they are possible in real time or discussions that would have to be tailored. But certainly for investigating the advantages by looking at some past cases, it is pretty straightforward. And as I said, for lower level stuff, we already have archived reanalysis data of various forms available to explore. Again, the full forecasts aren't necessarily there to long times, but that would be easy to extend.
Are you planning some for WACM? I mean, or a bit higher?
I missed the question. Could you repeat it, Simone?
You said you did it for the ChemTop model right now.
So the long stuff we've done is for the ChemTop model. Other people have done shorter periods with various other models, and Nick Petitella from HAO in particular did some work with Wacom and is actually working with Wacom X now. So both Nick and Ben have, again, significantly more physical science expertise here and would need to be involved in a discussion to temper my optimism, but I'm pretty optimistic about at least being able to test these methods as good alternatives.
Okay.
Yeah, so somebody asked in the chat about the computational cost, and the DA is an ensemble, and when we do nudging, we just do a single run. So
no,
that's
I acknowledge right away that there's more cost for doing this, and there's also significant advantages in getting the balances and the other things. So again, I'm suggesting it's at a minimum worth evaluating so that you can make a rational decision about whether extra costs might be worth it.
Absolutely.
I think in any event, even if we wouldn't use this for forecasts, for post-mission analysis for ACLIP, it sounds like a really great opportunity to investigate. So thank you.
I will also note, we've been talking here mostly about the dynamics, but we have a fairly mature capability to do full cross-species, cross-dynamics assimilation and a capability to turn the impacts of those things on and off. So you can actually go the whole way to full chemical numerical weather prediction where the chemistry just looks like part of the whole weather system, or you can let chemistry observations just impact the chemistry or subsets of species, and all these combinations are there. And again, Ben has explored some of these, and other people in the field, of course, are exploring these options too.
Ben.
Yeah, so there are a couple of things here. Looking at doing, first of all, the new nudging is on the same number of layers than the regular CAM, so that we can directly compare nudging to geos or nudging or doing the data assimilation. It would be on the same grid. Then what I've been trying to look at is to nudge to my own reanalysis, and that was not as good as doing the ensemble. But my ensemble was just running with 30 members of CAM, and I believe Kevin has been running 80 members. So the same way we do the chemistry better, CGD and CESL is doing the dynamic better using more ensembles. And so it would be interesting to look at the impact of nudging to the Dart reanalysis from Kevin. When I look at my own assimilation and nudging to geos, with different variants of the nudging, including nudging to my own reanalysis, the Dart assimilation is the best for just a field campaign I've been looking at in Korea. Then for chemistry, doing chemistry and met assimilation, that's another story we can talk online about.
And I'm just going to jump back in for a minute. The CAM reanalysis is from 2010 currently through the end of 2018, and it's available on the RDA. I mean, you can grab it tomorrow if you want. It's actually easier to get to than Mera in some ways.
Mm-hmm. The other thing is for stratosphere. I'm not sure how it does work for the stratosphere because there is not that much weather observations in the stratosphere, and I believe it was with CAM and not higher top model. Analysis, right?
That's definitely a concern. So we weren't thinking stratosphere when we're doing this. Again, these things can be done. I think there's really good potential at this point for trying to find some collaborations to explore what's worth pursuing.
Mm-hmm.
Great.
This is Dan. Has there been any discussions with the initialized seasonal prediction and being conducted by Yaga and others in CGD? Because I'm a little worried now that when they're proposing to add many layers in the troposphere and lower stratosphere, that the disconnect between the reanalysis used as an initial condition from Mera and the number of levels and the model grid the model used for the forecast will be quite large. So it seems like they would be the ones that should be perhaps leading the charge on this, because they'd be able to assimilate with the same number of vertical levels to get to their initial condition for their forecast part. And then, I think that's probably the biggest. Obviously, it would be good to have some assimilation of constituents too. But I think having it sort of seamless in the dynamics would be quite nice. But are you aware of that? That was my question.
No, I wasn't sure if Yaga was with us or not. So again, these things could be done, and we discussed a lot with Yaga before she went. There were both computing cost issues for Yaga, and in particular, concerns about real time. There is no doubt that real time introduces additional challenges. And at the point when the way Yaga's funding was structured and other things, her need to be doing stuff real time made the project, I think, more high risk than anyone wanted at that point. Glenn Romine did a significant period of real time numerical weather prediction stuff in M-Cubed a few years ago. And so these things can be done, and we could certainly do whatever grid. The details of the grid are almost irrelevant mechanistically to doing the data assimilation. So whatever configuration Yaga is working with moving to the forward, or other folks, we can test the data assimilation. Exactly how that fits with people's funding views, with how often they want to do it, and with computational constraints are things that need to be discussed. We are preparing to float the idea of a sort of revolutionary project to do a long period coupled assimilation over decades, over the next few years, to support primarily CSM sub-seasonal to longer prediction, but that tool would be valuable to a whole bunch of other players, including chemistry folks for these purposes. So we're going to start floating those ideas again. We did float them with Joe Trivia as the CGD lead about 5 years ago, and we're going to be thinking about those things again.
I mean, when you do that, it may be good to think about maybe waiting for the workhorse model to do that, because that will be much more valuable for us as well if we have the stratosphere that is represented.
And there's no doubt that this would be on the timescale of the workhorse model, because there are also data assimilation issues that are being pursued for the coupled data assimilation by folks in CISL, CGD, and elsewhere. And so I think on a sort of 2-year timescale is which such a project could come to maturity. One of the possibilities, and again, I'm getting a little ahead of myself, but one of the possibilities is to try and sneak this in between before the CMIP7 compute eats the next machine. So there's ways to think about doing this stuff.
That sounds good to me.
Great. Any other questions about data assimilation and nudging? Nudging does work for SC spectral element also. Going back, there was a question about land modeling. Dry deposition is calculated in the land model, and then the velocities are passed back to the atmosphere model. There's always room for improvement. If anybody's interested in helping work on that, welcome. Collaboration on that.
I think we had discussions in the WCAM group about community needs. And I wonder what the community thinks outside NCAR on what is required, what is the development. And there's a lot of development going on, of course, outside, and it would be good to know. Or yeah, just to hear about things that are new if anybody wants to say something.
Yes, that'd be great.
So Simone, I didn't quite understand what the question was. Could you repeat it?
Oh, Luisa, do you want to repeat it?
It would be great if there are other people that we haven't heard from or mentioned so far who have are working on some developments that they might want to share back with us, or.
Okay.
new things that are going on that we don't know about?
Well, I mean, on the dynamic side, you already heard it on the earlier part of this working group meeting.
Yes, I meant of the 59 participants, many of whom are not at NCAR and we haven't heard from. Maybe they have, I just want to make sure everyone's welcome, feels comfortable sharing what's going on, what they're doing. Or if you have any science questions that you've found the model is not quite sufficient for, and the need for some developments, not that we have time to do that, but it's good to share with the community and maybe find people to collaborate with who could help on those developments. And while you're thinking about that, I'll just show the Musica slide as our ongoing efforts to coordinate development of chemistry and climate, chemistry, gas and aerosol. For those of you who missed it, it's our the framework to really be able to do multi-scale aerosol and chemistry. And we have a paper that's been accepted in BAMS that Gabby Pfister led. We're working on an implementation plan, and so we really would like people to become involved. And we have a number of working groups on chemical schemes, aerosols, emissions, multi-scale physics, whole atmosphere, data assimilation, and the model architecture for really coupling chemistry and aerosols as separate modules that can be put together into a suite that are then coupled to a host atmosphere model such as CAM or MPAS. And this is closely tied to the development of SEMA that you maybe heard about yesterday also, which has a workshop coming up. So that's one of the ways that we're trying to coordinate new development. And at the moment, Musica version 0 is a configuration of CAM-CHEM, but eventually it may, these modules should fit with other models such as FV3 or any other model with the same standardized interface or MPAS. So invite you to look at the web pages, and we're going to be having some tutorials at some point later this summer on getting started running the spectral element regionally refined version, and try to come up with other ways to keep in touch on development through these working groups.
So I have a comment from the WACN side, and I'm going to put Dan Marsh on the spot here if he's still on. Isn't there development going on for improvements in electron energy precipitation and production of NOx, medium energy electrons?
Yeah, we're working on several ways of improving on that in terms of specification of the input flux. We've got a funded NSF project looking using Firebird data and the Van Allen probe data, and working with several colleagues in Scandinavia on improving the specification of input. So obviously, if we get something that is suitable to replace our current input files, which are CMIP6 files, we'll make those available. And if you want to do not only the precipitation right, but if you want to do the production of nitric acid correctly, then you have to run with the D region code. But that's been integrated now, and it's a standard chemistry package that you can choose. Now, one question there is that you're going to have to figure out how to, if for Musica slash, 80 or 75 kilometer CAM, you're going to want to get that upper boundary condition correct for NOx. So in which case, we're still going to have to, that's a general topic. How are you going to handle the upper boundary? And is that still a situation where you're going to have to piggyback, run Wacom first before you can run chem to get your upper boundary forcing? Or is it the opinion that it's so far away it doesn't really matter in terms of, I think for the stratosphere it does matter, maybe for the tropospheric air quality forecasting it doesn't matter, but that's a topic we have to think about in the future.
So Luisa, there's comments about the Musica, about the...
Yes, I was just trying to answer when I'd lost my mute. So there are tools to create these grids, and we are putting together a web page and GitHub links and things to help the community have access to them. But yes, you can make a grid, pretty much a refined region for whatever you want. You have to do a little bit of work to make sure it's stable. This grid nicely goes mostly over the ocean. We're trying to figure out a new grid for Asia and dealing with the Himalayas. In general, it's flexible, but at the moment, you then also have to create the emission files on that grid, and we're putting together the set of programs you need to do to generate the emissions on the grid. So in general, it's doable, and hopefully we'll put together some documentation and tools that will make it easier for people.
There's another
Mosaic.
Yes. Somebody else want to answer that?
Yeah, so you have one slide, Luisa, is about the nitrate radiative forcing, that I think.
Yeah.
That is the different time period. So this is for the nitrate direct radiative forcing, and for a period from 75 to 2010, and it can be more important for nitrate and in the future. And this is for direct radiative forcing, and the cloud forcing can be also comparable, even larger regionally.
One comment, I think we did not release the model yet because we don't still have the coupling properly included between the cloud and the aerosols, but we'll work on it for the next release. Is that right, Xiaohong?
Yeah, so we are targeting releasing the CSM 2.3, right? So maybe it's end of the year or something. I don't know the timeline for the next future. Yeah.
Yeah, hopefully be done by then.
I don't either know the timeline. Luisa, do you know the timeline for the next release, actually?
No, I don't think anybody said. So 2.2 should be released in early August, and I haven't heard anything specific about 2.3, but I had heard end of the year. But and if we had things ready, I think we could, we can be part of the push to get something out there. But seems like we should have all these things done by the end of the year. Though the time always goes by much faster than we think it will. Anyone have any other questions, things we should discuss? More chat. Well, while you're thinking about that, I will jump to, we've been asked to to give our opinions of the tutorial, CESM tutorial. Chemistry and Wacom have always been a pretty small portion of the tutorial. And we're hoping that the Musica tutorial will be something that addresses the needs of the chemistry modelers in the future, but also with all this lack of ability to meet in person, we're thinking about different ways of having tutorials and interacting with the working groups. I think there are going to be questions in the survey that everybody's asking. It's going to be asked to complete after the meeting, but I just wanted to highlight that the tutorial committee has been asking these questions, and if you have any thoughts about it or the Musica, what a Musica tutorial should look like, I'd certainly be happy to hear about those too. So for Musica, we're gonna, I think at the moment, just try to put together some things online. We might try to have a webinar sort of online activity, but mostly, or virtual meeting sort of tutorial, but most of it, hopefully we'd have documents on a website that people can learn how to run the regionally refined CAM-CHEM and get started that way, instead of having a group of people come in and in person helping each person. But so I don't know if anyone has any thoughts.
Well, it's probably quite late for people. I mean, the whole day meetings, and we know that online meetings is much more exhausting. You don't get the coffee. I mean, some people may get the coffee in the afternoon, but this is, yeah, this is an intense, I would say, day or days to have and still come.
Yes.
So I don't blame anybody for falling asleep, probably. Or...
I've only fallen asleep once, and I am awake now. But no, it seems to have gone on forever, you know.
Yeah, it's hard. I mean, it's really difficult to have an online discussion. Although I'm really excited that we have so many participants in our meeting.
There is one last question about aqueous chemistry, I see. I think that's going to be, well, I don't know. Does anyone want to say anything about that? I don't think there are immediate plans, but certainly something we'd like to add to the model. I know there will be activities as part of the Musica working group, I think, to look into implementing aqueous chemistry on particles and clouds. So sign up for the appropriate Musica working groups and be in touch with people there and try to, hopefully we can get, that will move forward at some point.
Yeah, Louisa, can you talk about a little bit about you just mentioned about the COVID, the CSM2 involvement in the COVID studies, like the yes.
There was
and this is like climate chemistry climate interaction or something like this kind of opportunity.
Yeah, the IPCC question was well, I think there's opportunity for many sorts of questions on, you know, the group, people in ACOM have been thinking about air quality impacts, but I think the IPCC would be to look at some climate impacts. They weren't very specific. They were proposing running for 20 years, and we suggested that might be more appropriate if CESM2 did some short 1 or 2 year more ensembles member simulations to look at a radiative impact. But I think that's all up in the air. We were waiting for the emissions, which seem to have just been shared. But I think there's going to be some group trying to do something over the next couple of months. So I think there's some hope to get a paper in to be considered in IPCC as one of the rushes to do something.
Are there any other groups working on that with regard to chem or CESM? Would be interesting for us to know too, and to collaborate.
Yeah. Once we put together the emissions, we can share those as well.
Yeah, this is a challenge because the emissions will be in somewhat uncertain when they are just derived, from estimates of reductions in different sectors. On the other hand, as Ben already mentioned, there are the top-down from satellite data, I guess, estimates that are more realistic, and so this is all taking more time. I don't know, Ben, if you want to elaborate somewhat more on that, what you're planning to do.
There's nothing sure for now. And top-down emissions are only for a few species. So the only thing we know is that the CAMS emissions would be made available by next month at some point. And so if we grid that on a CAM one by one, then maybe that can be shared.
Yeah, it is a challenge also regarding climate effects because the climate effects may be quite small. So that's another thing that to think about how to do this. Peter, did you want to say something?
No. Thanks.
I saw you shortly coming in the picture and I thought, oh, maybe.
I clicked the wrong button.
But now you're on the spot.
Well, I certainly don't feel a need to stay here until 4:30. Everybody's tired and nobody else has any other questions. Encourage everybody to participate in Musica however you'd like, and check out our webpage for working groups. And if you have any other questions and developments for CAM, get in touch with us. And thank you all for joining.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Thank you.
Yeah.
Thanks.
Thanks, Susan.
Thanks, Ben.
Thanks, Louisa.
Thanks, Elizabeth.
So I just did another download of the chat. I don't know if that would be useful to you, but if you have your chat open, there's 3 little dots on the right-hand side.
Oh, yeah.
And then you can download it too.
Oh,
and then
okay.
if you grab that blue link, it'll take you right to where on your computer it saved it.
Oh, yep, good. Super. I think we saw most of it and
yeah, just in case.
Answered it, but that's helpful to have a record of it.
Yeah.
And it looked like you recorded it.
We did, yeah. It was, it's just been evolving the whole process.
Yeah,
and we just thought, better to have
Sure.
a copy of it. We don't need to post it, but just in case.
Yeah. Sounds good.
Yeah. Well, great. Thanks. And I'll talk to you again soon.
Okay. Thank you.
Yeah. Bye.
Bye.